Hello guys, what's up? Happy New Year. I'm very excited to present you this first tutorial video for this year. Today we're talking about the complex design, modeling and calculations in using the fantastic software Autodesk Structural Bridge Design. In this session we're talking about the different process, method and approach how you can easily design this complex suspension pedestrian or suspension footbridge in using Autodesk Structural Bridge Design, and how you can put some calculation, checking, and so we're talking talking about many cases. We're talking about many demonstration, and to me it's a real pleasure to present you this topic session about Autodesk Structural Bridge. The second video we're talking about the stage bridge, who will show you step by step how you can design and maybe in the far or the future calculation this such as a complex bridge. Sometimes we're talking about the software can't do it, but today I'll show some hidden tools and benefit in using this software to design and calculate this complex structure. Do not be long. Today we're talking about the session. You know me, it's not the first time to present you. You know me, it's not the first time. So if you need some help, some consultations, you have some questions about Autodesk product, don't hesitate to contact me from my mail address. Or if not, you can just contact me to my LinkedIn page. So today I'm talking about the suspension a footbridge. Why I'm talking about? Why it's very important talking about the suspension bridge? So before to begin this topic session, I will recommend you to searching by maybe and try to download this import books we're talking about cable supported bridge concept and design, third edition, right by Neil G. Jamesing, Christoph Stott and Georgiakis. So why suspension bridge? As I know, for the short theory, I can just say a suspension bridge is a type of bridge in which the deck is hung below suspension cable on vertical suspender. The first modern example of this type of bridge were built the early in 1080 year. The suspension cable must be anchored at each end of the bridge, since any load applied to the bridge is transformed into tension in this main cable. In the family of bridge system, the cable supported bridge are distinguished by their ability to overcome large spans. At present, cable supported bridge are enabled for span in the range from 200 meter to 2000 meter and beyond. Thus covering approximately 9% of the present span range. The deck or stiff ring guards the cable system supporting the deck, the pylon or tower supporting the cable system, and the anchor block or anchor pier supporting the cable system vertically and horizontally or only vertically at the extreme end, as you can see for this capture illustrations. What again talking about? So a footbridge. So let's talk about a footbridge. So also a pedestrian bridge, pedestrian overpass or pedestrian overcrossing is a bridge designed solely for pedestrian, while the primary meaning for a bridge is a structure which lengths 2.8 high above the ground. A footbridge can also be a low structure such as a boardwalk that enable pedestrians to cross where fragile or meshly land. For rural communities in the developing world, as you know, a footbridge may be a community only access to medical clinic, schools, business and market. Simple suspension bridge design have been developed to be sustainable and easily constructed in such as area using only local materials and labor. As you can see, this is some most as well known as suspension footbridge. You can see there is many kinds construction in many countries, from old here and to modern. This is some old and old suspension bridge. As you can see, the Glass footbridge in South Korea, you can see it is well known. You can search on YouTube, on Google to have many to know more about this. Some example of a footbridge is some as suspension. As you can see here, some fantastic footbridge, very well known. For example, some footbridge designed by the well known and famous architecture Santiago Calatrava. You can find some his bridge design and construct in across the world. For example, the Zubizuri Bridge in Bilbao is most of the famous suspension bridge with aesthetic and architecture overview. So it's very important to know how to make the digital modeling, how to 3D dimensional modeling of any complex bridge. It's the purpose of our tutorial. Our objective of presentations today is to show you easily how you can just try from simple manipulation to design and calculate a complex bridge. As you know, it's very complex to have this such as model design as a first preliminary design or modeling in this software. It's a reason why we are always trying to make some workflow. The important to using AutoCAD 3D, because it's firstly this some line, a 3D line to model this complex structure, and imported from AutoCAD to structural bridge design, and how you can have such as model. But in yourself, if to try to make this same model without try to use the first AutoCAD, it will take you consume much time. It's the reason why today I will show you the benefit of using AutoCAD 3D and how you can just export it, this model, the beautiful simulation, the beautiful seamless streamline workflow between AutoCAD 3D and Autodesk construction bridge design. So we'll begin by the demonstration. And so as you can see here, we have our 3D model. Is a 3D model. So AutoCAD allow me to have easily, to not to lose time to design this complex model of a pedestrian bridge. As you can see, the same for our state bridge. It's very easy for me to use it. So in Autodesk structural bridge design, it's possible, but you need to know some many parameter and some instruction will take you consume much time. So it's the reason why I always try to make this accelerate the workflow in using. Firstly, you begin in AutoCAD 3D and go up for Autodesk structural bridge design. So after you save and you go here in Autodesk structural bridge design, you create new. I have a new bucket. I must put some code. We're using the British standard codes, of course. And after you are going to preference, you will check everything here. Appearance, graphic card, and check enable hardware acceleration to not have some error, a message of errors. And after you need to to add, to save. I did a suspension footbridge. Yeah. After, you need to go to structure definition. In structure definition, you will have two capabilities. Firstly, you go to option, data, bridge type. Which bridge type you want to design and calculate. Road bridge, rail bridge, or footbridge. You check, you go to footbridge, and here you have two possibilities to design your bridge: line bridge, just for line beam, or refined model. I need the refined model who help me to export it, to import it a model. So as when I click here, you see there is two possibilities: general structure or bridge structure. So I import the name browse. So here I go back to bridge, here state, and here you can see I have a design bridge. We have this and we have this. I click here, I have here this. As you can see here, if I'm checking some things here from my layer, so when we import it, you can see it will be able to design from zero. And so I'm going here, you change the appearance one, the unity, I'm working in meter, and after I have it, click OK. This is my bridge, but uncompleted because some instruction does from the workflow from exported doesn't really be read by our structure. Firstly, the line for our deck limits and for our arc. So you need to redesign again. You click here and you go here, and so it gives you some tools who will allow you to design your bridge. Firstly, I'll begin by the arc. So I'm going here, arc, and click. You see, quickly I design my arc. You rotate. Okay, from this side too, I click here. So we have our arc, and I made the same from this part. You see, you can see here, I put the same. So this is our complete model. When we have it, so we have our, there is no difference between our structural model and our AutoCAD 3D model. So after all, you can just go to materials. Yeah, you need to OK, save, and go to 3D Symbol model. Go to material. You need to define material. And our structure will be not in concrete, so working just for steel design. And by the way, you can just add for reinforcement. We don't know, maybe the deck can be in concrete. You press test no. You can just put here, put just to a material configuration. So we need working, we're not working with BIM because we're working with just a design sections, not design section, but yeah, design section, not that design BIM. When you go at this a menu, you'll have some information how to create your design menu, your design section. You can go with parametric shape or regular shape or style shape. So to be quickly, just for this demonstration, I can just go for steel, and for steel I need some form, some hot finish, not cold former, some finish for circular, for my arc, circular hot finish, and this circular for I'll begin by the deck, because here circular finish from the deck, and it will be the size serial, it will be a 3. That is for this 2 limits of the deck, and the properties you choose between steel or concrete, it will be grade steel, and you can just rename it, you make it deck turb. You click OK, you go here, and you create another parametric, say not just style session. You need to create suspension cable. It will be a circular hot finish. You put some value, the design serial, the within range, and you can just put a 140.3, and you need still your rod suspension. You click OK. The you put this the same way. You create other section for the arc bridge. For our arc bridge, you need to circular hot section, a circular hot finish, and maybe the value. We put this, and you go steel, arc bridge, and so arc bridge exactly, and we have traverse. Yeah, we need to put traverse. We go there, we create another section, steel section. It will be in hash, not hashes. Yeah, we go here, circular odds, it's the value 244.5, and traverse. Yeah, after bracing, our bracing, we will use always the circular hot finish and circular 168 bracing. Okay. After to do all these things, we have all properties. So okay, what we can do is to continue our modeling, to put some traverse, because as you can see here, there is no traverse, and you go back, you save, and you go back at the structure definition, you go to some model, and we need to create some things like this to create traverse. You go there, you need to create nearest I'm create traverse nears. Yeah, we put the same here, of course, and so I can make intersection for the rest. So here we have the entire almost modeling. So we can just make some traverse to allow. That's a traverse method. You need bracing. You go sub-member, so we can just put some bracing here. It's very easy. You go there, you click here, you go there, you click here. It's very easy. And so here guys, here we can say we have the entire modeling. So when we finish our modeling, you need just when we finish our entire modeling, we go maintenant we go now to the type of a structure. You need, because we have been defined some elements, and you go here, design. The design is just for the deck tube. So for the deck tube, as unfortunately when we design in AutoCAD, we did make some layer correctly. So here we can just click the element. That is the deck tube. All these elements. It's very easy. Very easy. You see, it's very easy to do it. Some deck tube. Not for this. You can just check here the properties. 40 let me check, excuse me, spread structure properties. Let me go here and let me check here member 2000. Let me go here, expire. We'll coming back because we don't need this here, the join. $60 to $165. 60. Okay, click here. So here is that. We have this. First, we click OK. We need to assign. The second will be the suspension tube. So we will continue, and once we can do aft. So we need for the suspension. For our suspension, let us uncheck this. Our suspension, we need to create the design tool, suspension tube, and so we can just make the same. We click for all suspension tube, all, I say all. It takes some times. All suspension cable. So after to check to assign after to assign members for the suspension tube, you can see, you click, everything is okay. You click all. After you add another design section, the section 3. Our section 3, it will be just for arc bridge. For our arc bridge, we made the same. It's very simple, you know. Here we just make some assignment. It's very fast, very fast. Yeah, we finish. Okay, after we make for our traverse. Our traverse, we begin here to change this. Yeah, the beam element has already been assigned. Our properties will alright. We can just change our properties, and we apply for add. So we made the same. After to assign all these beams, and for the traverse, you click OK. You made the same for the bracing, because we have just only bracing, and our bracing is that. You do the same. Okay, after to do that, you click OK. But you will go back to assign a finite element for the surface, to assign for some plates, to assign our properties. You need to go back to definition, and from definition you need to go to submodule member, and then you need to working like you go here, click here, and you need to go here. Sorry, not beam, not like a beam, but like if endpoint. You go here, you click here. Yeah, we define our finite element for our deck. You can go here, you need finite element. It gives you some all information about global X. Global X is just the current position in the design, and the global, the join, the intersection, and so you made the same for the rest of our the rest. For you made the same. You do the same for the rest of our design. You know, you do the same, and we finish our finite element defined in our structure definition. So we have this because here will help us allow us to add some assignment for the deck surface. So after you go to the properties, you go to finite element, you define the thickness. You can put our deck can have 2 millimeters of thickness, because it is steel. It's not concrete, it's just a steel. Yeah, it is steel. And deck bridge, everything is in steel, not in concrete or composite construction. And you can just go here, assign. You just click around all these elements here, and so we have all this assignment. Yeah, we just come finish our modeling. You need to see this structure in 3D, and in 3D what you see, fantastic view. You know, everything is okay, everything overview, everything is okay here. You know, everything you have been defined, we define everything is okay for our deck, for our bracing, for our arc, for our suspension cable, for our bracing beam, for our traverse beam. Everything is okay. So after that, we just come to finish our modeling. The next step is to go back to our structure definition to add some elements, supported nodes. When you go to supported node, click to join. Just you can put here, you can just select all join. You click here and here only, here and here only. you can define the type of supported, the in function of a degree of freedom. Here we have the direct strength, the rotation. If here for our supported from X movement is blocked, Y movement is blocked, and Z movement, the Z movement, direct restraint constraint is fixed. For the rotation strength, we can just block, maybe we can just block the rotation from X and Y. We can just see the rotation from Z. It can rotate, we don't know, and we click OK. After all of these things, we go to the next step. The next step is to add some, we have some properties, so we need to add some loads to have some first structural analysis results, to add them. For instance, of materials, some first result offers a static analysis the structure. So in this case, you can see here, we'll put just some small loaded. As you can see here, we have for vehicles, for railway, and so for bridge deck path, you need to create a carriageway. From this session, I don't show you how to create the carriageway. We help us to add some special loads, to add some vehicles, mobile dynamic mobile vehicle here. As you can see here, to add some defined special vehicle on the structure, to add some movement roads, some movement loads, some for our beam, because this is just a pedestrian bridge. We can just add firstly the finite element, maybe eternal road loads. So we need just to select everything here. Everything here, I'm sorry, and you can just add the first load. Maybe I put 5 kilonewton per meter. I click OK, and after I need to add some, maybe for finite some temperature loads when there is some creep and shrinkage. When there is some creep from a shrinkage inside of our members, our deck, because it is still deck, so there is some when it's hot and cold, so we need to add the first button. We put a 20 degrees and minus 15 degrees. We put the same here inside our structure. This is the behavior. We will see the behavior of a temperature loads apply for our deck bridge, and we click OK. So it's just these two. We can put many lumped mess. In this case, you need to go very far to make some dynamic structure analysis and beam, and so that will just limited for this. After you can put some combination, and so after to check, you go to option tension grades. You can add it for 50. Okay, and you can click here. Hence calculation is preferable. Element 5 are not apply. You can just go to here, check which this 15 elements. You can just verify here, find okay, this element, yeah, they are right. I'm here, and we can just go here. Yeah, they are right. It's just for our suspension tube. We apply this here. We assign. If you don't finish to assign everything, you can just make any calculation can't be able, so that is okay. So we need to launch our calculation. You see it's completed, everything is very okay, and when everything is okay, no warnings, no error, it means we made a beautiful and good modeling and analysis. Go to result, we can just see some first result. As you can see here, we have the first difference for displacement in the Z, in the Z position, in the Z displacement in the DZ. We can see some results here. It can give you some elements such as it's for beam verification, load case, it's for internal displacement, and you can just check here for rotation. Yeah, there is some rotation. You see our structure is unstable. As you can see here, we have some rotation. If our structure, it means that we can have some twisting, that's some strength of twisting, and so we have the value here, displacement, the big displacement, join this, and so in Y, in W, X, Y, we have some displacement, all this things. So we can have some supported rotation. The supported rotation, it gives us the value from the supported, the internal apply. You can select a result. There is no selected. We have just all value. For the beam, we can have some diagram for the if Z reaction. Here we have if Z reaction, the big value. You can go here, we can do the member, the result, main result. You can see here and check here. You see the result for each beam here, for reaction in Z, reaction in FY. There is some small reaction member for FX. There is some reaction in FX. You can have the result that we need to have some moment, the diagram of moment. In this case, you can have some results here. You have the maximum and the minimum of a bending moment here for the beam. So we need to see the reaction for the surface element. That is for the finite element. That's for our surface deck. You can just see for the force member affected, the stress here. We can get the stress here for the internal apply force. We can see for the temperature doesn't have any effect for our structure, from cooling, from shrinkage, and from shrinkage. There is no, when it cool and when it hot, there is no significant impact for our structure, for the dilatation of our steel members. So we can just check the same things for the bending moment. For the bending moment, we see here for the temperature doesn't have any effect. For the internal force, yeah, we have some from the extremity, but from the supporter we have some maximum moment, which allow us when we begin the process of building to reinforce here from some beams, and maybe we can just change or increase the stiffness of our deck. Remember, triads, we have principal volume, and so we can try to verify the deflection shape, bottom stress. The bottom stress, we have the value. We can just check the membrane stress. We can check other things here. We can see here the load case, no compilation we made. We can maybe to conclude training session, we can just go back here and put some surface influence to check some influence surface. I'm going just there. I just selection 3F, and we can just launch the analyze here. It doesn't work maybe, but you can do the same. You can do the same to verify everything here. So for me, it was just I'm very happy. It was a pleasure for me to present you this session. The next session, we're talking about the stage bridge. We will show you how easily you can design and make some beautiful. Thank you so much, and see you later. Bye bye.